All right, so we have the final unit of the year. You guys excited about that? All right, so this is surface area of prisms, and this can be found in 12.1 in your books. Let's get right to the objective. We only have one to find the surface areas of prisms. Simple enough. All right, let's move on to some vocabulary. Okay, so a polyhedra are solids with flat faces. So the faces are the polygons, and the lines where they intersect are called the edges. So, like this here, that would be a polygon. Any of these faces, would be a polygon. Notice that's a parallelogram. The lines where they intersect, so this right here, whenever we talk about edges, that's what we're talking about. That's an edge. This is an edge here. Okay, so those are all different parts of the polyhedra. Let's get that out of there. Prism is a polyhedra with two congruent parallel faces and a set of parallel edges that connect the corresponding vertices to the two parallel faces. So here we have this face is parallel to this face, and all of these edges are parallel. So this would be a prism, this figure here. And the bases are the two congruent, that's one thing to notice, and parallel faces. So this triangle right here, that's a base. And this one down here is a base. And those two figures are congruent and they are parallel. All right. The lateral edges are the parallel edges joining the vertices. So that would mean this is a lateral edge, this is a lateral edge, and this is a lateral edge. All right. And the lateral faces are the faces of the prisms that are not bases. So in this case, there's three. There's this one here, there's this one here, and then there's the one in the front, which is this one that goes all the way across. Okay? And a little bit more vocabulary. The lateral surface area is the sum of the areas of the lateral faces. So that excludes the bases, but all the other faces, that would be the lateral surface area. The total surface area is the sum of the prism's lateral surface area and the areas of the two bases. So that should be pretty easy to figure out. Lateral, total, should be a pretty much a no-brainer for you. All right, and something to keep in mind, if the lateral edges are perpendicular to the bases, then the lateral faces are going to be rectangles. So when this is the case, you're going to often see the word like right in front of the name, like a, I don't know. We'll get an example when we come to it. But if you ever see a polyhedra described as a right, whatever, then that would mean that you can assume that the lateral edges are perpendicular to the bases. Okay, and that the lateral faces are rectangles. All right, so let's look at the diagram. We have to find DB and find FB based on the diagram below. So we're given that AD is 6, that EH, this piece right here, is 8, and that GC is 24. All right. Now, I'm going to tell you, I know it's not written down, but I'm going to tell you that these are perpendicular. All of these are perpendicular. Okay, so keep that in mind. That means that you have rectangles here. So let's start off by finding DB. So that's this piece here that we need to find. All right. Again, we know that AD is 6. And since this is a rectangle, if EH is 8, that means that AB is also 8. So we know this. So basically what we have here, even though it doesn't look like a right triangle, this piece right here is a right angle. So what we're actually trying to find is a triangle. Okay, and we know that one side is 6 and the other side is 8. So we're trying to find this piece here, which happens to be the hypotenuse of the triangle. So looking at it, we can already see it's part of a couple polygons, but as triangle ADB, we already know 2 of the sides, and we can use the Pythagorean theorem to find DB since it is a right triangle. So we have 6 squared plus 8 squared equals DB squared. So that means that DB has to equal 10. Because 6 squared is 36, 8 squared is 64. Add those two together, it gives you 100. Okay, and if DB squared is 100, DB is the square root of 100, which is 10. Okay, now let's find FB. So we now can add that DB is 10. And we need to find FB, which is this diagonal here. Okay, so if all these are perpendicular, you'll notice again, now it's with the diagrams, you really have to use kind of your mind to picture this, and if it helps, break it into pieces. So FB, okay, you've got to think in terms of 3D. That's what we're trying to find. Okay, FD is this piece here that we'll need, and DB we know is 10. Now, if GC is 24, and these are all rectangles, that means that ED is also 24. So again, we've got a triangle that we're trying to find. And if we were to lay it flat, it would look like this. We've got 10 and 24. Okay, so now that we know DB, we can use the same technique, in other words, the Pythagorean theorem, to find FB. So 10 squared plus 24 squared equals FB squared. So FB has to equal 26. Okay? Easy enough. The hardest part is going to be picturing this, because these are supposed to be 3D drawings. Obviously, they're not going to pop out at you, but they represent 3D models. All right, so now we need to find the diagonal of a cube with an edge length of 7. So the cube has an edge length of 7, and since it's a cube, that means that all the faces are squares that are congruent. So AB is 7. Okay, AD is 7. Okay, what we need to find is the diagonal here, FB. Okay, so to find that, we need to know this, which just so happens to also be 7, and this, which we don't yet know. Okay, so if we take just this first, okay, and we flip it so that we see it flat. This is 7, and this is 7. Okay? It's a 45, 45, 90 triangle, so that means the hypotenuse has to be 7 root 2. Okay? So then to find the diagonal, we can use the Pythagorean theorem with triangle FDB now. So with triangle FDB, this is 7, and this is 7 root 2. So we need to find this. So we use the Pythagorean theorem. 7 squared, which is 49, plus 7 squared times, or plus 7 times the square root of 2, quantity squared. So that ends up being 7 squared is 49, square root of 2 squared is 2. So that equals 98. So 49 plus 98 is going to give you the square root of 147, which you can simplify to 7 times the square root of 3. Okay? And last example. So if we have the following figure, we need to find the lateral surface area, okay? And then we need to find the total surface area. So first we need to establish what our bases are, okay? Which sides are parallel to each other? Well, we've got this triangle here that's parallel to this triangle here. Obviously, these other sides aren't parallel because they intersect at these edges, and those are not, okay, if they intersect, they're not parallel. So let's start off with the lateral surface area, and I'll slide this up here. Okay, we need to use the Pythagorean theorem to find the missing side of the triangle, because we are missing this piece here. You can't assume that that's also 5. Yes, it looks like it's 5, but you can't assume that. So let's use the Pythagorean theorem, because it's not given to you. So 5 squared plus b squared equals 13 squared. So b has to equal 12. So again, never go off of the picture. All right, so now that we know that, we can find the lateral area of each of the faces. So that means that it's this face here, this face back here, and this face down here. Okay, so lateral area equals 5 times 20. Let's get rid of all this so it's less confusing. So since this is 20 and this is, perpendicular here, that means that we've got right angles all over the place. So if that's 5, this length is also 20. So we've got that kind of represented down here. 5 times 20, which is 100. Next, we'll do this side, which we said was 12. So this rectangle here, okay, which is 12 times 20, okay, which equals 240. And last but not least, the bottom part, which is this one here, okay, and that's 13 by 20, which is 260. So just add all those together. 100 plus 240 plus 260 equals 600. So we answered the first part. Now we need to find the total surface area. All right, so again, let's move that up there. All right, so we already know, and that shouldn't be total surface area, lateral surface area, which we said was 600. So all we need to do is find the area of the bases. So this one here and this one here, and we know that this is 12. So we have triangles, so we're going to use half the base times the height. So if I took this, and let's make it easy on ourselves, because when we have a right triangle, so if we flipped this so that the right angle was here, okay, and we said, okay, well, I've got 5 and 12, or 12 and 5, however you want to do it, and then double it since we have two bases. We can figure out the total area pretty easy. So when we have a right triangle, the base is pretty obvious, and the height is pretty obvious, because when you have a right triangle, one side's the base, one side's the height, and that would be the two sides that are not the hypotenuse. So we do half of 5 times 12 times 2. Now when you do that, these cancel out. So you're left with 60. So we take the total area equals the lateral surface area plus the area of the bases, which is 600 plus 60. So our answer is 660. All right, so this last unit is all going to be about area and volume. It's actually pretty easy. There's really not a whole lot of formulas to remember, except the ones from the prior unit. So you should be fine. Only got a few more weeks, and then we're done. So don't quit yet. All right. So next we have surface areas of pyramids coming up. So get ready for that. Have a good one.